they do on the best day 2.1 to 2.5.
Do it again, sorry.
The quizzes we are doing, not quiz, but homework.
Homework, yeah, homework. Whatever section we get through today, and hopefully that will be the end of chapter 2, will be due by the day of the test. Cool. All right, here we go. So, I'm sorry, which one?
150.
Oh, in chapter 1?
Yes.
Whoa.
Oh, okay. So, I mean, this one tells you... can somebody... We might be using this a lot today, so can somebody... Thank you. You are my designated house lights person. Okay. Refer to exercise 79. So if you didn't do that, you're not going to have a freaking clue what to do with this problem. So exercise 79 in section 1.3 explains what the hell they mean. Exercise, where to go? 79. This is number 150. So it talks about exercise 79 in section 1.3. So exercise 79 talks about this rule of 72. It says if 72 is divided by the interest rate, the result is about the number of years it needs to double the investment. So if the interest rate was 8, I would take 72 divided by 8, and that's 9. So every 9 years, the investment would double. How are we doing so far? So some of you guys, when you did this homework, you very obviously didn't go back to do this because you did all kinds of nifty stuff. But that's what they're talking about. Now, even if you understand what they're talking about, you're like, how the hell do I apply it to this? Well, your interest rate is 9%, right? So rule of 72 says take 72 divided by that. What's 72 divided by that? All right, let me do it. All right. So a prerequisite for this course is not that you have to have a business degree, right? So you do not have to understand currently how somebody came up with this rule. In a later math class, you can actually prove it. And this is just an approximation. Right now, it's just a rule that we are told. So we're going to apply the rule that we're told. So if I know the annual interest rate, to figure out how many years it's going to take for my money to double, I take 72 divided by that interest rate. That's the rule that I'm going to apply.
So
right?
it would be 8.
Yeah, so if I take 72 divided by 9, every 8 years this will double. And I want a total of 24 years. So some of you guys were like, what do I do with 3? Because there's 3. No, you just go, after 8 years, how much money will I have? 50,000. After 8 more years, that's 16 years, right? 100,000. After 8 more years, that's 24 years. Twice 100,000 is?
200.
That problem's done. Next problem. So this is just a problem as far as, you don't have to understand why the rule works. We might not even have enough math to prove that it works. But I know the rule. I want to apply it. And that's real life. We get rules all the time in real life. We don't know why they work. We just know I want to apply it. So this is kind of like mimicking that. So just applying the rule correctly. Some of you guys are trying to go back to your simple interest formulas and all that kind of stuff, but that has nothing to do with it. This is a little shortcut that somebody proved, and it's not exactly perfect. You won't have exactly 200,000, but it's a pretty good approximation. You do it really quick in your head. All right. The crowd gives me no reaction. Right.
Yes. Can you explain that one more time, please?
So this rule, what does the rule say? It's the rule of 72. So if I had an interest rate of 12%, I'm going to put a lot of money in that account. 12 freaking percent. Yeah. So the rule says take 72 divided by whatever your interest rate is. What's 72 divided by 12? 6. So every how many years my money will double?
6.
Every 6 years my money will double. So if I want to know how much money I have in 12 years, and I put $10,000 in, well, after 6 years it's now 20,000. After 6 more years it's now 40,000. So you just double it every so many years. That's the rule. I think some of you guys are like thinking you're supposed to understand why it works. No. This happens to us a lot in real life. We have rules that we know. We don't know why they work, but I know what they do. I know when I put gas in my car, it works. Can you explain to me exactly how it works? Some of you might be able to, but most of you know. Right? I can't fix a car with shit, but I can tell you the physics behind it. That's a normal physicist. I know the theory, but I can't freaking fix a car. All right.
Just please, could you please tell me what is exactly the homework right now?
So
because we've done that.
We barely got into section 2.4 last time, real quick. So we're totally done with 2.3. 2.3, you should be into it. If you're in section 2.1, you're a little behind, right? So today, you should have been able to turn in 2.1, 2.2, and that's why the quiz was really focusing on that. You guys with me? So if you're just starting chapter 2, you're a little behind, right? You should be into 2.3 right now, if not having it almost done.
Just wondering, we can turn in all the sections at once before the test, right?
Sure, of course. Don't do that too often. You totally can. Everybody in here could turn in all your homework at once, and you could even turn it in on the day of the test, and you're not late. But 2 reasons why that's bad. 1 is, holy shit for me. And 2, you won't get the homework back to study for the test because the test is happening right when you turn it in. So the homework is supposed to be sort of like a communication between you and me so you can study for the test. But you have until the day of the test because we all have a life, things happen. So I want to give you a little bit of time to let things happen and then catch up. All right. Anything else from the homework? Yes? 2.2. This one here?
Yeah.
All right. Don't worry. I think you might have gotten, I don't think I really signed that one, but
Oh, you did it?
you're fine. You can ask me whatever the hell you want to.
No, it's okay.
No, it's good.
Oh, okay.
Everybody has to know how to do that. I could even give that problem on a test, and they'll go, oh, good thing you asked that, because it gave us. So this kind of problem was, they give you the equation, so it's not a real word problem. You just got to know what x and n represent. So what does n represent? Number 74. Yeah, the HIV infections, right? And what does x represent? The year x. So if I'm in year 2015, as we are, I would make x equal to 2015. But it tells you where does it work. It only works past the year 2000. And that kind of makes sense because in the 80s, that's about when AIDS was realized that this existed and people started getting, it was a crazy, quick steep. And then it kind of leveled off a little bit. So there's like 2 different equations. And that's why this one only works for years starting in 2000. Then it became sort of linear instead of like, oh shit. Right, then it became linear. So they ask you, in what year will the number reach 970,000? That's easy, Jeff. It's 2004 because I can see your magic book. But where do you put, the important thing is where do you put what? So the number they give me is 970,000. So which variable does it go in for? And what exactly will you put in for n? What number will you put in for n? Because what is n in? Thousands. So if I wanted 5,000, I would put 5 in for n, because the thousands are part of it. Is that, you got to be careful. N in thousands, n in hundreds, n in whatever. So you don't need the extra zeros at the end, right? You'll be getting stuff like the year 2487. Why would I be worried about the year 2487? If you put that in, 970,000. So put 970 in for n and solve for x. Yes, ma'am. Okay. So 75 says the number n of inmates. So n means the number of inmates, and x again means the year. Don't think that's always true. You got to always make sure what the hell the specific problem's talking about. Here's the formula for it: the number of inmates versus the year. Determine the year in which there were 1.5 million inmates. So their favorite year seems to be 2004. Now what's interesting to me is the quickest way, not exactly piss me off, but the quickest way to make me annoyed is to have the complete wrong work and then the answer shows up. guys with me? Do you understand why that would piss a teacher off? And then I'm thinking, have previous teachers never looked at your work? I had a teacher, let me real quick story, just to let you know that I'm not perfect either. He would just go around the room and put a check mark and put it in his little book if you had a paper with writing on it. So I'm like, I forgot to do the homework, so I just turned the previous homework over, and then he put a check mark in. I was like, yay. So, I mean, I've taken advantage of teachers, if they're stupid, it's really easy to get around stuff. I'm not. But how? So where do I put what number? Yeah, 1.5, because n is in millions, thank God. So I don't have to put comma 000, comma 000. N is in millions, so I put the number 1.5 and I put it in for which letter?
N.
N, because I want that to be, that's the number of inmates. That's a really good letter to use. Number of inmates. N makes sense. Is that cool? Okay. Okay, which one?
And after that you saw.
Section 2.4.
Oh, yeah, you had a question. I'm sorry.
No, I said if you put 1.5 million for N, and then this equation, then you solve it.
Yeah, then you just solve for X, because they want to know what year, and X is the year. So now if you solve for X, you'll see what year makes that happen. Cool.
2.4, I have 2 questions.
All right.
Number 48 and number 51.
So let's see. 2.4 is the one we just barely got into. I like it. So 48 says... Oh, let me get the instructions in there. There. So they give you the formula, and real quick, and you're just looking this way the whole time, but you're okay. So what shape am I talking about in all those problems? A cylinder. Cool. So a cylinder looks something like that. For me, that's really good. Now, real quick, anybody remember what the area of a circle is? I was going to do this later, so we might as well do it now. Yeah, why the hell is it that?
Because it's pi and...
This is really kind of cool. Watch. I'm going to do this semi-quickly, because I don't think anybody maybe has ever seen this. But I don't know what the hell is a circle. But if I can rearrange it into a shape that I know, I'm going to try to make that circle into a rectangle. I'm going to do it up here. Ready? I like the look on the faces. So can you imagine, if I had a circle in construction paper, someday I'll actually do this.
It will fall down.
Probably not. Say again?
It will fall down.
It'll fall down? Oh, no. I would probably have you guys do it on your desks. But if I had this circle and I cut it in half, you with me so far? Mm-hmm. Cut that bad boy in half. So then it looks like the top of the kid on South Park, because he's Canadian. What's the circumference of this circle?
Pi d.
Good. Pi d, pi times the diameter. I don't know if you guys remember that. And what's the diameter related to the radius?
Half of it.
Yeah, the radius is half of that. So the diameter is twice the radius, right?
Yeah.
So another formula for circumference is 2 pi r, because 2 times r is the diameter.
Yeah.
Let me stop there for a second. You guys have been attacked by geometry there. Okay. This is kind of cool. I love this. I would, wouldn't I? So the whole thing is 2 pi r. All the way around is 2 pi r. How far is this? All the way around is 2 pi r. That would be pi r. It's half of that, right? It's halfway. So this is pi r. Stay with me now. You don't even have to take notes on this, because I'm never going to make you do this. I just want to show this to you once in your life. Now I've got this circle cut in half, so then I can cut out to the edges little triangles, but I'm not going to cut through the edge. It's going to sort of be like the little thing where you open it up and there's little people. You ever seen that? Yeah. So I'm going to cut out, but I'm not going to cut through the edge, so I can open it up like that. Can you guys imagine that? So I'm going to pick this up, and I'm going to open it up, and it's going to look like this. You can do it, Jeff. Right? Let me stop right. Can you guys see what I'm saying? That's why we better visual know. If I pick this up and I open it and put it there it is, right? Mm-hmm. All right. How long is this? How long is this?
Pi
Pi r. It's just pi r. I just straightened it out. I just straightened it out, and all the teeth are just going down. So pi r. Stay with me. Stay with me now. Stay with me now. I do the same thing here. Cut it, cut it, cut it, cut it, and I open it up and I put it. You guys see what I just did? Right? If I do the same thing on the bottom as the other set of teeth, and I just put it in there. Right? So now this is the grill of the circle. How tall is this? What is this for every triangle? What is this? What is this? That's from the center out. So that is the what? Radius. That's the radius. So that's radius tall. So what's the area of that rectangle? Length times width? Pi r squared. Holy shit. So r times pi r is pi r squared. So any area you don't know, you can try to rearrange it into an area you do know. Bam. I don't know, has anybody ever seen that before? Some of you guys are like, I'm not sure, I just saw it now, because I don't know what the hell you just did. If you didn't get that, it's not a huge deal. I'll be a little sad, but you don't have to ever do that for anybody. You know the area of a circle is pi r squared. Some of you guys now realize why. Right? Okay. So the area of this circle down here is pi r squared. And this is height h. So how many circles do I have stacked up? I got h of them, don't I? Do you guys kind of see what I'm saying? So if I have a penny, and I know its area is pi r squared, and I stack so many pennies up, what's the total volume I just went through? Pi r squared times the number of pennies. So the volume of the cylinder is the circles times how many there are. That's why it's pi r squared h. Let me stop there. Everything I just talked about, beginning with the circle I drew and ending with me explaining where that formula came from, is nothing you ever have to do for anybody. I just want you to know why this makes sense. Why that's the equation. They gave you the freaking equation, didn't they? That's where the equation comes from. Now, let's use it. 40, which one? 40. So in 48, I know the radius is 2.5 feet. Oh, here's the evil part about this. The height is 1.5 yards. So can I just put 2.5 in for R and 1.5 in for H? No. Of course not. We know that they have to have the same units, right? And normally what I want to do is take the yards and turn them into feet. How do I turn 1.5 yards into a number of feet? How many feet in a yard? 3. I'm going to assume you know that. You live in America. You got to use our freaky ass measurement system. That's actually based on the foot of the King of England, way back when. I don't know if you guys know that. Have I told you that?
Yeah.
I told you all that crap. All right, I'll stop. So 3 feet for every yard. So 1.5 yards is how many feet? Times 3. 4.5 feet. So now it's just plug and check. Now you put the 2.5 in for the radius. So you got to square it. You put the 4.5 in for the height. Hopefully, you guys should have a calculator. If it has a square root button, most often it has a pi button. So take a look at your calculator and see if you can find your pi button. Pi is not equal to 3.14. That is so desperately not true. Pi is equal to 3.14, 1596, blah, 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 blah. That's as far as I remember, because that's all the space I want to dedicate to it in my brain. But it goes forever. Okay, so is that decent for that? That's 48 in section 2.4. 51. Oh yeah, I got it. I think I'm gonna use the book, and if you're smart, you're just copying down all the answers. So solve for y, right? Neat. I see Tom Cruise in underwear. So. You don't understand what I just said, sorry. 9x plus 3y equals 6. Solve for y. Now I told you what to do. I'm not going to let you. So it says solve this for y. We kind of got into this last time. If you can solve an equation, you can solve this, because that's an equation. It just has less numbers than we're used to. Where's my y? That's what I want to solve for. Where is my y? Which term is it in?
3.
3y. So there it is, right? You're all like, what do you mean? It's right there. Can't you see it, Jeff? So I find my variable and I get rid of the other shit. That's how I solve a problem. So if I had 9 plus 3y equals 6, what would your first step be? Minus 9. See, you automatically do it. The second I just put, all I did is put an x there, and all of a sudden your brain goes, oh shit, it's the same stupid thing. You found where your variable was and you got rid of the other shit, right? Yes, ma'am.
So if it's 9x and 3y and it just says solve.
They would never do that to you. You can't solve it unless it's an equation. So that if they didn't give you equal something and they said solve, then I am never going to use that book from that publisher again because they're crazy. You see? So if you think they're asking you to do that somewhere, let me know because they
if
can't.
there's always 2 variables, they'll ask for which variable they want.
Oh, okay, I see. If they just said, okay, now I'm with you. So if they had this whole thing and they just said solve, that is remarkably evil. They have to tell you what to solve for, of course. The minute I get more letters, I can't just say solve.
Okay.
If I only have one letter and I say solve, you know it's that letter. Yeah. So in here they said solve for y. So what do I want to get rid of?
9x.
9x. So that goes away. I got 3y equals
6 minus 9.
Good. These are not like terms, so you cannot slap them together. And here's where people made mistakes. There was one problem in the chapter 1 homework. What do I do now? And the best way to do this, if you divide this side by 3, you have to divide that side by 3, but I'm just going to, well, let me just do this. Both of these have to be divided by 3. Right? So if you just do this, bam, and make it a 2, and the 9 is still there, that's not fair. That 6 got cut down. That 9 is getting cut down too. How does it escape? So really what it is, it's 6 over 3 minus 9x over 3. That's how you break it up.
Oh.
So here's that problem, 24x minus 60 over 5. I've graded so many of those, I remember. You got to break it up and reduce both. You can't just do one and the other guy escapes. So then what is this? 2 minus 3x. Bam.
It doesn't matter if it's 3x minus 2 or 2 minus 3x.
Totally does.
Because
Totally matters.
Because this one says negative 3x plus.
There you go. That one's fine. If you say 3x minus 2, you're wrong. If you say, what is 3x? Is it negative or positive? So if I write negative 3x, is 2 positive or negative? Plus 2, these are the same damn thing because they're both the right sign. But if you write 3x minus 2, oh, they're both the wrong sign, that's wrong. It's the opposite of the answer. I like it. But this, I'll totally accept this. I'd rather have the positive thing first than the variable first. All right, cool. Oh, yeah. All right. So anything else from homework? Yes?
Number 36 and 2.3.
Oh, okay. All right. So this one says in 2009, there were 3 times as many millionaires in Kentucky as there were in Rhode Island. Together, a total of 84,000 millionaires lived in the 2 states. Find the number of millionaires in each of the states. So together, in both states, there were 84,000 millionaires. All right, so you attack word problems pretty much always the same. You don't have to draw a millionaire. So you don't have to worry about drawing a picture. What's the very first step? Players. Who are the players in this problem?
Kentucky and the Kentucky.
Yeah, millionaires in Kentucky
And the Lola,
and millionaires in Rhode Island. Those are my 2 players, right? That's the 2 parts of this. And then the equation is going to come from that together statement, right? So which one is going to, now the second step is, which one is just x? You put step 1. Step 2 is which one's just x?
The Lola.
Rhode Island, good, because, well, now let's be careful. Let's take a second and make sure we're all right. So 3 times as many in Kentucky as in Rhode Island. So if there were 2 in Rhode Island, there would be 6 in Kentucky, right? So I'm just doing that thing I did the other day where I can just put a number in for what I don't know, just to see what I do. So sure enough, if I know Rhode Island first, how many are in Kentucky now?
3x.
3x. Why is it, just a general statement here, if somebody said California has the most inmates, so California is the most criminal state, what's wrong with that statement? Does anybody know what's wrong with that? It's true. California has the most inmates, therefore California is just a criminal state. It's like Australia way back when we first populated Australia with prisoners. What's wrong with that statement? What's wrong with comparing Kentucky to Rhode Island in pure numbers? Rhode Island is
More populated.
tiny. They can only fit so many people in there, right? In fact, Rhode Island is the smallest state. Okay. Geography is not my strongest. So that's why this, saying there's 3 times as many millionaires in Kentucky, you're like, big deal. What's the percentage? That would make more sense, right? All right, that's enough of that side note. Is everybody cool up to this point here? And I'm really desperately, this is the English names, this is the math names using their relationship. So one's got to be just X or whatever letter you like, and the other one's going to build off of that. Right? Now what's the equation I can make?
3x plus x.
Yeah, if I add these millionaires to those millionaires, I get
84.
Good. You don't have to put the 1,000 in there if you don't want to. Your answer is just going to be in thousands. So if my answer is 2, it's 2,000, so forth. Cool. And I'm going to let you finish that out. You should be able to solve that.
Yeah. It's not too far.
Okay.
I just want to know, I'm 57.
By the way, this was 36 before I get too far. Right? Yes.
D equals pi r squared is all.
Which one? Sorry.
57.
Oh, good. All right. So this is section 2.4. Here's that good old formula we just used. Number 57, right? There's absolutely no numbers in there because there's no 2 in there. That just means there's 2 r's, right? So how do I solve this? They say solve this for h. Yeah, I want to get h by itself. Or how many terms are over here?
3.
How many terms are over here?
3.
1. Pi r squared h. Is it plus any other terms? Minus any other terms? There's 1 term. So how many terms? If I put A, B, C, D, E, F, G, H, I, J, K, L, that's 1 term. There's no pluses or minuses. That's 1 term. It's not added to any more terms. So there's nothing to like subtract or add to the other side. I mean, this is almost too easy to believe what you have to do here. Why is the h not by itself? Why is the h not by itself?
Because it's multiplied by.
There you go. See, you're allowed to say that. You can talk about math in that way because there's freaking pi r squared with it, right? So, and what's the pi r squared doing to it? So how do I get rid of it? Yeah, see, that's the internal conversation you have with yourself when you're solving an equation. Why is my variable not by itself? Because this shit's doing this to it. Oh, undo it. Is it by itself yet? No, this shit, oh, undo it. And that's how you solve any equation. So I don't want the pi r squared shit. It's multiplying by h, so I divide by pi r squared. I divide by the stuff I don't want. And see there? Bam, bam. Almost too easy to believe, right? I'm not saying that to make you feel bad if you didn't know. I want you to realize sometimes problems are hard because you think they're going to be hard. Cool. All right.
So, yeah.
What's up?
What did you just do? You just divided.
Yeah, watch. If I said solve this for h, what would you do?
Divide both sides by.
Divide by 16. You would divide by, this is multiplication here, right? So whatever the hell is here, would you do something different for this one? No, you divide by that. So how would you solve this for h? How would you solve that for h? Divide by x. How would you solve this for h? Divide by yx. What am I'm never doing something different. I'm always, if the only thing is multiplication, how do I get the letter by itself? Divide by the other shit that I don't want.
But over there, so that's the end of that equation.
Yeah, so, I mean, I was lazy here. Let me write. So H is left alive here. You write on the same side. H is left alive here, right? Right, that's, H is the only thing left there.
Yes.
And then what's on this side? V over pi r squared. So I like it. One semester some student realized it's actually easier when you don't have numbers because you don't actually have to do any of the operations. Did I have to divide anything? No, I just got to, what's v divided by pi r squared? V divided by pi r squared. All right, good. I don't have to reduce anything because they're just freaking letters.
So can you do one that has a number with it?
Sure. Well, here's a kind of a different one. There. I like that. And I want to solve for D. Good. The worst part of this equation, why is that equation even worse than that one was? Because there's a what in that equation? Addition. No. There's a fraction in it, right? The denominator makes things worse, and I agree with you. We're human. We're going to make more mistakes with fractions than if there weren't fractions. So the beautiful thing is an equation, I can kill any fraction I want. So how do I kill it, like you said? Multiply by 3. So that's the very first thing I'm going to do. What always freaks me out is when people distribute this 3. Why does that not make any sense? Because it's dead. That's the reason. So I hate it when that disappears, but then that 3 somehow is still alive and goes through. Oh, it's dead. And so I get 3L equals xy plus d. Now how do I get d by itself?
Subtract d. I mean xy.
So you say to yourself, why is d not by itself? This crap. It's adding positive this, so I do the opposite. Subtract this to get d by itself. That's the internal conversation you have on every step. Why is it not there yet? Because this crap's there. Get rid of it. Is it there yet? No, this crap. Get rid of it.
But don't you have to do it on both sides?
Of course. Definitely. Of course.
So how are you subtracting xy from 3l?
Here, I love it. You ready? 3L minus XY does not equal the color blue or something, right? What is 3L minus XY? 3L minus XY. Bam. So that's what I meant. You actually don't have to do any operations. You're just collecting operations for somebody else. If somebody else happens to know what these are, they have to do it. We don't, because we don't know what they are. So don't think, and I very often I'll get this, people will get to this step, and you'll do this, and then the next step is this. And it's you thinking that you're supposed to do something with it. But this is subtraction, right? That's subtraction. What operation is this? How the hell? Right? That's like math Jesus level shit. Math Jesus came down and said, I want some wine. I got water. I want some multiplication. I got some... Right? Sorry for being sacrilegious, but that happens. Whatever deity you like, we'll do that. Flying spaghetti monster, whatever.
I keep asking this question, but is it same for when both variables are fractions? So you have a over b plus c over d, and then solve for d.
Ooh, that would be gross. But you could do it.
I am just asking.
Yeah, I don't think they gave you one like that.
66 is xy plus zy equals 5.
Oh, and solve for z. So the nicer thing with that problem is z is on the top. If you're trying to solve for variables on the bottom, that can get a little bit more disgusting. So there, the very first thing I would do, 66 says this. What time we got? This might be the last question I take. We got to get to the new stuff. What's it say, Jeff? X over y plus z over y equals 5. I'm completely allowed to kill that fraction. And why is it easy to kill a fraction? Because they both have y in the bottom. So how do I kill the fractions? Yeah, multiply by y. Bam, bam. Good. X is left alive. Z is left alive. 5 get picked up that y, dude. And then you're almost done. Yeah. How we doing? Hey, all right. So every equation is the same equation. Whatever's happening, you do the opposite of it. Really. That's it. You're stripping away all the shit to get at the X or the D or the Y or whatever it is.
So you said you're almost done, so... the next
Yeah, this one said solve for Z. So how do I get Z by itself? Yeah. Oh, and him gone, it's adding a positive, so I'm going to subtract X to get, yeah. Good. I was just trying to leave a little work for you guys. All right. So let's get into some new stuff. So I already showed you the area of a circle. So the area of a circle's formula is going to show up in section 2.4. The circumference formula is going to show up in there. The last thing about triangles that you need to remember for this section 2.4 is, who remembers how many total degrees are in a triangle? 180, like so. Whatever these three are, angle A, angle B, angle C, angle A plus angle B plus angle C has to be 180 degree measurement, right? Cool. So,
right now.
right now. So I'll kind of bring geometry back up every time we hit more geometry, or you can ask me. Plus, the very first thing I do when I have a brand new book as a student is I look in the front. I think I already said this, didn't I? Look in the back. So the back, dude, formulas and shit. And if you didn't realize, of course, very first thing you should do as a student is, what kind of answers does this book give me? And they give you, of course, you should be used to this, the odd number answers. And that's why your evil teacher assigns odd and even. Yes. Cool. Okay. So I want to get into section 2.5. This is my goal for today, was to get into this section. And the nice thing with section 2.5 is, if you know how to solve equations, you know how to solve inequalities. It's just that with inequalities, we also have to graph them. Right? And I can't remember if they make you do, they should. Maybe not. Not quite yet, I guess. Okay, not quite yet. Okay, so no interval notation yet, it looks like. I don't know if you guys have ever heard of interval notation. So we're not going to talk about it yet because it looks like it doesn't come up yet. I'm still getting used to this book myself. But just to remind you, let's do a straightforward problem, and then there's one place in inequalities that gets a little weird. I don't know if you guys remember. It's when you do certain things. Is that still going? Mm-hmm. Okay. So this is section 2.5. So let's just remember the basics of how to solve it and then how to graph it. So if I had... sure. Yeah, so the beautiful thing is there's only one difference between solving equations and solving inequalities. And we'll talk about that in a minute. But if you know how to solve equations, you know how to solve inequalities. You get the x by itself, right? So you, like you said, add 3 to both sides. And then divide by 2. Is that cool? Thank God. There's no new process for this.
X is less than or equal to 5.
So x is less than or equal to 5. Anybody remember how to graph that?
It's like go to 5.
Yeah, so first I put down there a
line.
number line, kick ass.
All and then it goes 0, 1, 2, 3, 4, 5, whatever you want to do.
Yeah, just put a few around the number you're curious about.
And then since it's a less than to equal to, the dot has to be solved.
All right, I like it. And we're going to update our symbols. We're going to be smarter about the symbols we use, which is why I thought they would be doing interval notation, but not yet, I guess. There it is. Hey, well, they made it optional. Screw them. It's not optional. So let me show you interval notation. It's going to make sense out of why we're going to change the symbols. And you want to change the symbols. So like you said, if it's equal to, do I want to include it or exclude it? Include it. And so the letter I starts the word include, right? It's amazing, Jeff. So the symbol I use is a bracket. I don't know if you guys, anybody ever seen that before? Instead of a closed circle, I'm going to use a bracket. Because I'm a math person, I got to make it harder. Okay, now you have. So if you wanted to put a closed circle down, I want you to put a bracket down. What would you use if it was not equal to? open circle. And part of an open circle looks like that. If I do that, that's a parenthesis. So instead of an open circle, you would use a parenthesis. That's all. So if I want to include it, I'm going to use a symbol that looks like part of an I. If I want to not include it, I'm going to use a symbol that looks like part of an open circle. So how the hell would this look? I want to include 5, right? I'm going to shade which way? Yeah, this points me in the direction I shade as long as my variable is on that side. I don't know if you guys know that. If I have the variable there, that's the arrow. Right? That kicks ass. So then I want my bracket to open that way, and then I shade that way. So the only difference between what I've just done and what you're used to is you would normally put a closed circle there, right? That's the only difference. So now we're using a better symbol, believe it or not. I know you guys don't believe me. You're like, what the hell? Keep it the same. How are we doing so far? You guys have all graphed inequality type statements before, right? So the only change I'm making is I'm using better symbols, believe it or not.
So to ask for the bracket when we're graphing it specifically, we're supposed to do that because I'm more familiar with like the solid circle and the open circle.
Cool. And so what we're doing now is we're learning better things. Yeah.
So we'll put like that if we put a dot?
Yes. So all you do is if you put a circle there, just put a bracket on top of it. That's all this is. And the reason we do this is because of interval notation. Somebody help me out. So this is a quick visual of what's going on. Interval notation is just a little more explicit. What's the lowest this number could be? What kind of infinity? Negative. Negative infinity. So it goes from negative infinity up to 5. And I put a bracket on 5 because there's a freaking bracket there. How we doing so far?
So if it's greater than, you put the arrow.
Yeah, we'll do another example here in a second. What do you mean by infinity? If I want to include infinity, that means I have to be able to get there. Can I ever get to infinity? If you think you're there, take one more step. Oh shit. Right? Because infinity just says keep going that direction forever. So I never include infinity. I always put a parenthesis on it. I can't include it because I can't get there. If you get there, nirvana you've reached, or you become pure energy like Powder. You ever seen the movie Powder? He's running that lightning, pure energy. All right, you guys are not with me at all. If you get to infinity, you have done something amazing. You must let me know. Never do this. This is real. I love when students do this kind of thing. They put infinity on there. You know what? So what's that? Whoa. So no, never put infinity on the number line. You can't. You can't get there. The shading represents infinity. That represents, this arrow represents infinity, right? Negative infinity in this case. Okay, maybe. Let's do another problem. So what's the only real new thing up here is these symbols. The bracket and the parenthesis. Does this make sense? This is just another way to say the same thing this is saying, right? But this is much more useful in future mathematics. I don't want to always have to draw a number line and graph. I just want to say real quick, I can use from 3 to 7. You put the symbols on there. Oh, okay. All right. Let's do another one. Oh, cool. We got time. And then we'll talk about what's different here. Let's try, well, let's see. We'll do 2 more before I talk about the difference. Let's do one more that's sort of like this. Greater than what, Jeff? I don't know, Jeff. Leave me alone, Jeff. You could do it, man. It doesn't really matter, does it? There. Right. Let's try to make it come out not a fraction, but I don't care, actually. We'll make it come out to a fraction.
Distribute first.
Good. So just like an equation, I distribute my 4. So what do I get?
4x minus 4.
All right, so these guys are just still there. Cool.
I like terms.
Good.
4x minus 2. Add 2 to both sides.
Good. Yeah, see all the same steps.
4 squared. Divide by 4.
Divide by 4. And what do you get when you reduce this?
5 halves.
Cool. All right, let's stop there. So would one work, for example? Would 1 work in this equation? Would 1 work?
Yes.
Is 1 bigger than 5 halves? No, because 5 halves is 2 1/2, right? So 1 would not be a solution to this problem. 3 would work, because 3 is bigger than 5 halves, right? All right, just want to take a real quick second to make sure we all understand what the hell that exactly means. So when you solve an equation, if I get x equals 3, that means only 1 number worked. When I solve an inequality, I can get infinite number of numbers that work. One whole side of the number line, and the other side doesn't work, right? And that's what the picture means. So how would I draw this picture now? What's 5 halves in between?
2 1/2.
Yeah, it's 2 1/2, so it's between 2 and 3. So here's 5 halves right there. What symbol am I going to use? Parentheses. So if you wanted this, just erase half of it and you're fine. Just make sure it's opening the right direction. Does this part make sense? Am I going to open it this way? No, because I want to shade which way? I want to shade up. So I'm going to open it that way. Shade up. What do you think, sir? Please, get me out of here. Sorry, sir, you're stuck. And then how do I write it like this? You see, it's really going to be the same thing, just turned around. What's the highest it can go? Infinity. So it's always from the lowest to the highest. And what's the lowest it can be?
5 halves.
5 halves. And what's on the 5 halves?
Half a circle.
Parentheses, I like. Let me stop there for a second.
Yeah. So every time you do a question like this, do you have to include infinity there?
If it doesn't stop anywhere.
Okay.
So it starts at 5 halves and it doesn't stop, and that's what this means. Right? Ain't no party like an infinity party. Because infinity party don't stop. All right. I apologize. All right, so here's the only difference between solving an equation and solving an inequality. And let me start with something really, really, really crazy simple to explain why this happens. Some of you guys remember what I'm talking about, maybe. -2 and 1, which one is smaller? So how would I draw the symbol pointing which direction? Pointing to the -2. That says -2 less than 1. And real quick, just in case you have any trouble with these symbols, which one of these symbols looks more like a lazy L? The first one looks like an L that kind of like, I'm tired, man. Right? It's an L, oh shit, it's a long day. That means less than then. Right? That's how you read it. It looks like an L, that means less than. That doesn't look like a G, too bad. That's the only other freaking option. That means greater than. You got the alligator and all that kind of shit, whatever way you want to remember it. So that's a true statement, right?
Yes.
I'm allowed to divide or multiply both sides by anything except 0. This is true? Of course I am. Not just because I'm the teacher. You guys can too. So if I divide both sides by -1, what does this become? What does this become? 2. And what does this become? Which one's bigger now?
2.
What did the sign do? Yeah. So when you divide, notice how I'm talking really slow. I mean, it's a good note. When you divide or multiply by a negative in an inequality, the symbol must switch. Why? Because it has to. I love the answer. Because it does. It's a property of numbers. When I multiply by negative, they change what side of 0 they're on. So now the bigger one is the smaller one is the bigger one. So that's why that makes sense. Okay, maybe. So, a simple problem that has that happen. What you got, Jeff? It don't matter, Jeff? Sure. Yeah. So it's not just is there a negative somewhere in the problem. It's what are you doing? If you divide or multiply by a negative, then you have to switch the sign. So what am I dividing by? Negative. Oh shit, I divided by a negative.
So x is greater than
Good. X, that has to switch. And that is -3. And then you can graph it, interval notation it. Yes, ma'am.
That works on like longer equations too.
Oh, hell yeah. So this could be like after I've done a lot of work, I get to this step. The minute I divide or multiply by a negative, I've got to switch the sign.
Technically, the sign could switch a couple times.
Sure, of course. Yeah.
If it's at the negative and it comes out as a positive, we still have to switch it, right?
If you multiply, if the number you put in there is negative, if you multiply by negative or divide by negative, you have to switch the sign.
Okay, so regardless if it comes out positive.
Exactly. So if I had this equation, what would you do?
Divide by 3.
Divide by 3. Divide by 3 to divide by negative? No. So then I don't switch the sign. The sign stays the same. I did not divide by a negative. I divided by 3. So the sign's not going to change. So watch this. Is 3 less than 9? Negative 9? No, let's start with the real estate. So let's do negative 3 is less than 9, right? Okay. It's not what I wanted to do. Screw you, John. Let's do it. Yeah, let's do this. 9. How am I going to do? Screw it, Jeff. We'll just do it this way. Try and come up with an example. All right. Let's do this the other way. I'll get there eventually. 9 is greater than negative 3, right?
Yes.
Still is not what I wanted. All right, you guys need patience. 3 is greater than negative 9. Yes, right. Yes, there it is. If I divide both sides by 3, what do I get? 1, negative 3. Which one's bigger? The 1 is still bigger. See, the sign didn't switch. Because I divided by a positive number. So it depends on what you do. It doesn't depend on what's in there. It depends on what you do when the sign switches. Okay, cool. And then this is saying, then you can graph it. Negative 3. It's going to go down, needs a bracket. Bam. You can interval notation it. Right? So that step doesn't change. It's just that sometimes you got to switch that sign. Cool. Oh, yeah. Let's see if I've missed anything. No. So, of course, we haven't done like, they're just going to make the equations uglier and uglier. They're going to put more shit in there. But you solve it the same damn way as always. Now, watch this. Here's an alternative for you. And then we'll head out. Oh, I got to give you guys the practice test. I'm holding it hostage so you don't leave early. So watch this problem. Well, this problem might be good to do it. So watch this. I wouldn't do this, but tell me if what I'm about to do is legal. Couldn't I add 3x to both sides? Why not? What do you mean?
Divide by
No. Could I do this? Could I?
No.
Of course I could. I'm not asking would you. I'm asking could you. Of course I could add whatever the hell I want to both sides, right? I could add w to both sides. I wouldn't. Stay with me now. So what's this? 0. And then I can subtract 9, right? And then I can do what with the solve to finish it? Do I have to switch a side?
No.
No.